signal. Okay, now uh, the question is, how can we calculate or how can we identify what will be the phase of this generated signal, right? Okay, for this we basically use a very interesting technique or very interesting diagram that is known as the constellation diagram. Okay, that constellation diagram basically has two axes or normal, it is basically a normal graph that has two axes, that is x-axis and y-axis. Okay, and it's basically works similar to polar coordinated system. Okay, that is, we basically use a point to represent a bit. Okay, and how this point work, the distance from the center to that point basically represents the length or amplitude. Okay, so the distance represents the amplitude, ampli, okay, and distance represent the amplitude, and the angle with respect to the x-axis, angle of theta, okay, and the angle with respect to the x-axis basically represents the phase. Okay, and as we can see, we have two BPSK or two analog signal here, right? So for this two analog signal, we will have 2 point, and we will connect this 2 point to find another point, and this connected point will represent this combined signal element. Okay, how this is work? Let's have, or let's see it with the example. Okay, as you can see that, look at this, for this first bit it is 0 and it has an amplitude. Let's say the amplitude is 5 or 10 or something, and it has a phase. For 0 this has phase of 180 degree, right? So for amplitude we will use the length from this distance, and for phase we will use the angle. Okay, so as you can see, angle with respect to x-axis. Okay, so the angle will be 180 degree, right? So it will be somewhere in this axis. Okay, and this part will represents the length. Okay, let's say this one is 5. Okay, so this will, or this point will actually represent these signal elements. Now go to these signal elements. These signal elements have same amplitude, but it has phase of 270 degree, right? So 270 degree, that means 90 degree, 90 degree, 90 degree. So this combined will produce 270 degree. So this point will be somewhere near here, right? And now we will connect this 2 point. Okay, this is okay. Basically the point will be here and here. So if we connect this 2 point, it will connect this point, right? Okay, so this point will basically represent this signal. Okay, and how we will calculate the amplitude and phase of this signal? Same as before, that is, the distance from the center will represent the amplitude, and the angle will represent the phase. So what will be the angle? If we calculate it in clockwise, anti-clockwise, then it will 90 plus 90, 180 plus 45, that is 225. Okay, so for 0 0, that is 0 and 0, the angle will be 225. Okay, and if we calculate this in clockwise, then it will be 90 plus 45, that is 135, and as it is calculated in clockwise, so it will have a minus sign, and the angle will be minus 135 degree. Okay. Okay, let's see for the second one. As you can see, for left one, it has started from 0, so the angle will be somewhere here, and this one started from here, so the angle will be somewhere here. Okay, so if we combine these 2 points, we will find this point, that is 1 0, that will represent 1 0. And what will be the amplitude? The distance will be the amplitude, and the angle will be, as we can see, if we calculate clockwise, it is minus 45 degree. Okay, and if we calculate anti-clockwise, this is basically 270 plus 45, that is 315 degree. Sorry, 270 plus 45, yes, 315 degree. Okay, and let's say for the third one, if this for this 0, it has an angle of 180, so it will be somewhere here, and for this one it has an angle of 90 degree. Okay, so this will be somewhere here. Okay, this is 90 degree from x-axis with respect to x-axis. Okay, so if we connect these 2 points, it will produce a point here, so this will represent 0 1. The amplitude will be this length, and the angle will be 90 degree plus 45 degree, that is 135 degree. Okay, so this point has an angle of 135 degree, and for this one, it has an angle of 0 degree, so it has a point here, and this one has an angle of, sorry, 0 degree, it has a point here, and this one has an angle of 90 degrees, so it has a point at here. Okay, so if we combine these 2 points, it will produce a point here, and it has an angle of 45 degrees. So for 1 1, the angle will be 45 degrees. Clear? So this is how we can combine these two signals produced by binary phase shift keying and calculate the angle and amplitude of the combined signal. Okay, so how had we calculated it? We basically fixed the 2 points for this signal and for this signal, then connected these 2 points and calculated its length and amplitude, right? So this is all for QPSK, quadrature phase shift keying. Okay, so using this quadrature phase shift keying, we basically can represents other shift keying too. Okay, so here is an example. As you can see, it is an amplitude shift key. As we can see, for one, we have used an amplitude and an angle of 0 or phase of 0 degree, and for 0 we have used no amplitude and phase of 0 degree. Okay, so this is basically that on off keying, or amplitude or 0 amplitude and shift keying. Okay, and for binary phase shift keying, we have used this constellation diagram. How? Let's see, for one, we have used a fixed amplitude and a phase of 0 degree, and for 0 we have used again the same amplitude but the phase of 180 degree. Okay, so this is how we can actually represent any phase shift keying using the constellation diagram. And if we are using multiple shift keying and combining them, then we can actually calculate their angle and amplitude based on this type of calculation. Okay, and here are some other examples of quadrature amplitude shift keying. As we can see, let's say this one represents 4 different patterns of 2 bits. Let's say this one 0 0, this one 0 1, this one 1 0, and this one 1 1. So how do we calculate the angle and or phase and amplitude of these 4 different patterns? For 0 0, as you can see, it has no amplitude and 0 phase. For 0 1, it has an amplitude. Let's say this one is 5, so the amplitude will be 5 and the angle or phase will be 0 degree. Okay, and for this one, how do we calculate it? This one is 5, this one is 5, so this one will basically be 5 square plus, as we if we use Pythagoras, right? So this one will be um, okay, 5 root 2, that will be the amplitude, and the angle will be 45 degree. As you can see, this one is 45 degree, right? And for this one, the amplitude will be again 5 and the angle will be 90 degree. Okay, so from a constellation diagram, we basically can identify what will be the signals elements for different pattern of the bits.